We've all had that one teacher, right? The one who made a really tough subject suddenly just click. The one who made learning feel, well, like magic. But what is that magic? Today, we're going to try and capture it. We're going to unpack the special kind of knowledge that makes expert teachers so good at what they do.
Just think about it for a second. What was it? Was it their passion? The way they just knew how to explain things? Or that one perfect analogy that suddenly made everything make sense? The thing is, we all recognize it when we see it. But for the longest time, figuring out what it is has been a huge mystery.
And that's our first big topic, the mystery of great teaching. We can feel it when we're in the room with an amazing teacher. We definitely see the results, but pinning down what they're actually doing, that's been the real challenge. And this really gets to the heart of the problem that's stumped educators for years. I mean, if you can't even articulate what makes a great teacher so great, how are you supposed to train new teachers to be like them? How do you help a good teacher become a master of their craft? It's really like trying to capture lightning in a bottle.
Well, researchers, they love a good mystery. And back in the 1980s, they finally gave this magic a name, a formal identity that would kickstart a completely new way of thinking about the art of teaching. They called it Pedagogical Content Knowledge, or PCK for short. Now, what's so cool about PCK is that it's not just about knowing your subject, like being a biology expert. It's about knowing how to teach that biology to someone else. It's the special sauce, It's what separates a brilliant scientist from a brilliant science teacher.
The guy who pioneered this idea, Lee Shulman, he just put it perfectly. PCK is basically the teacher's secret toolkit. It's filled with the best analogies, the clearest examples. It's knowing exactly where a student is going to get tripped up and having the perfect demonstration ready to go to clear things up.
So, problem solved, right? We've got our name for it. Well, not quite. Turns out giving it a name was one thing. Actually trying to capture and document it was a whole other beast entirely.
So why was this so ridiculously hard? I mean, if these expert teachers have this knowledge, why couldn't researchers just, ask them to write it all down? Well, the reasons are actually pretty fascinating.
Okay, so there are a few big reasons PCK is so slippery. First, a lot of it is tacit. It's unspoken. It's instinct that teachers build up over years and years of practice. It's also super context-specific. What works for one class might totally bomb with another. Plus, teachers don't really have a shared language to talk about this stuff. And finally, its boundaries are just blurry. It's not some neat little package you can define.
And for years, that's kind of where the story stalled. PCK was this amazing idea, but it was just invisible. That is, until a group of researchers decided, okay, if we can't see it, let's build a toolkit to help teachers show it to us. Right, so these researchers at Monash University in Australia took a totally different approach. They figured, instead of us trying to figure this out from the outside, let's create a process that helps these expert teachers explain it themselves from the inside out.
So how does this toolkit work? It has two main parts, and the analogy is brilliant. First, you have the content representation, or core. Think of this as the blueprint. It's where a group of expert teachers get together and map out all the big ideas for a topic, and just as important, where students usually get stuck. Then you have the papers. These are like snapshots, real stories from a real classroom that show exactly how a teacher brings one of those blueprint ideas to life.
And this really shows you how they work together. The core gives you the what. It's the map of the territory you need to cover. But the papers, they give you the how, the vivid real-world stories that show an expert guide actually navigating that territory with their students. All right, so that's the theory, but what does this actually look like when the rubber hits the road? Let's check out how this toolkit was used to decode the teaching for a classic and famously difficult science topic. Yep, we're talking about particle theory. The idea that everything is made of tiny, constantly moving particles. It sounds simple enough, but for a young student, it's incredibly abstract and really tough to wrap your head around. This is a topic where a teacher's PCK is absolutely everything. So, using the toolkit, a group of expert science teachers first built the blueprint, the core. They all agreed on the absolute must-have concepts students needed to get. And notice, it's not just a list from a textbook. They specifically included that crucial last point. This whole thing is a model we use to explain the world. That's a huge insight.
And this is where the snapshot comes in. Meet Rhonda, one of the expert chemistry teachers in the study. This quote just gets right to the heart of PCK. She knows this topic is hard. not just because the science is complicated, but because it demands a massive mental leap from her students.
So how does she help them make that leap? Well, this is one of her papers. She has her students make these little cardboard magic glasses. And when they put them on, that's the signal to stop thinking about the big world they can see and start imagining the tiny world of particles. It's such a simple, creative way to make a totally abstract idea feel real.
Oh, this is my favorite example. An expert like Rhonda just knows that diagram A on the left, which you see in a ton of textbooks, is super confusing. See that solid line at the top? It makes students think there's a skin on the water, separate from the particles. She knows that diagram B on the right is way, way better because it shows that the liquid is the particles. That's not just subject knowledge, folks. That is pure, 100% pedagogical content knowledge in action.
Okay, so we can see how this toolkit makes that expert knowledge visible. But so what? Why is this so important? What are the actual real-world implications of being able to capture this teacher magic?
Well, the so what here is massive. This isn't just some interesting academic exercise. This work gives us a practical way to get past vague ideas about good teaching and move toward a system for actually understanding, sharing, and building the expert knowledge that really makes a difference.
I mean, just think about what this makes possible. Instead of boring, generic workshops, you can have professional development built around these real blueprints and snapshots for specific, tricky topics. New teachers can learn from the collected wisdom of dozens of experts, not just one mentor. And maybe most importantly, it finally gives teachers a shared language to talk about their craft, which can elevate the entire profession by making its unique expertise visible and valued.
And get this, this wasn't some idea cooked up by a few people in an ivory tower. This breakthrough was the result of a huge team effort. More than 50 science teachers worked together for 2 years, sharing their secrets, testing these ideas, and refining the whole process. This was a system built by teachers, for teachers.
Which really just leaves us with one final, powerful question. For so long, the incredible expertise of our best teachers has felt like an art form, powerful, intuitive, but almost impossible to pass on. But now we have a way to see it, to map it, and to share it. So if we really can bottle that magic, what does that mean for every student, in every classroom? What becomes possible then?